just for my interest, can you give us some insights on quantile regression?
You want to know about quantile
Yeah,
regression?
yes, sir.
How much do you know about it? Like, what is your perception? Why did you ask this question? Are you working on something that requires this?
No, just for my interest. I just want to know what is the quantile regression and what's its use. If
how did you get? I don't think quantile regression has been taught in any of your postgraduate or undergraduate courses, right? So how did you get to know this?
Just searching web,
searching
like
things.
Yeah.
Okay. So you know what is usual regression,
yes,
right?
Yes, sir.
So where you try to look at conditional mean of y given some variable x. Okay. So what you do in quantile regression is that you look at the conditional distribution of y given x. In some sense, if you look at the conditional distribution of y given x, then it gives you the complete information about the behavior of y when x is given to you. Okay. So if you just look at the mean of that distribution, that is your usual regression. Okay. So what quantile regression tries to capture is, it tries to capture different quantiles of that conditional distribution. So in a nutshell, that is what quantile regression is all about. Okay. So effectively, you are interested in capturing the conditional distribution of y given x, because that will tell you everything about behavior of y given x. And when you earlier studied regression, you only concentrated on the mean of that conditional distribution. So quantile regression is just that. That is the definition. Okay. Then you have different ways of computing the quantile regression. Like just like when you have the usual regression, you solve the least square problem. And when I was giving the lecture, I told you about the least absolute deviation problem. That gives you the median regression problem. So it is like calculating the conditional median of y given x. Okay. And that's a special quantile regression, right? Median is a quantile. That's the 50th quantile or 0.5th quantile, if you like. Okay. It is the 50th percentile or the 0.5th quantile, if you like. Okay. So, if you ask me what is quantile regression, what is it about, that's all I can tell you. But if you have any further question or if you want to know anything more about that, then I will try to answer that.
Sir, my question is kind of like a follow-up to Shweta's question. Actually, so we hear about applications of statistics in different subjects like biology, chemistry, physics, and even social sciences. Now, as an MSc...
social sciences is probably most classic, okay? Not even in social science. Yes. It's sort of started by a lot of the social scientists, actually, okay?
And as an MSc student, the last time I studied those subjects was in school. Now, how do I go back, if I'm interested in doing those subjects, now applying my knowledge in those subjects, how do I go back to that? Because I don't have any formal
training. You really don't need to go back. What did you study in school? Did you study, for example, biological science?
Yes,
okay.
I studied biology.
Did you learn about Mendel's work?
Yes.
What do you know about Mendel's work?
I know basics like...
the basics, yeah. What do you know about it?
The contingency tables and...
That's statistics, isn't it? So you don't need to go back. You have already been there. Okay. That's contingency table. That's statistics. Okay. So you had this Mendel's experiment with a single factor. You know about Mendel's experiment with two factors. And you have heard about the law of independent assortment there. Yeah, that is independence. That's probabilistic independence you was talking about. Okay. So that is how it was. Okay. So you have already seen those things. And when you have done, have you done any economics or such things at any level? You probably haven't done. Those who have done social science and economics, okay, they probably have seen the application of regression there. So anybody who has done a little bit of economics at a slightly beyond high school level must have seen some application of regression there. Okay. So it's, if you have been into that subject, you have already seen that. Just try to remember, nothing more than that. Okay.
I would like to supplement one thing. Since we have talked of use of statistics in sociology, maybe I can tell you one thing, application of statistics in literature even. Just give Google search, did Shakespeare write a newly discovered poem? It's a very interesting paper where statistics is used to find out one writing Some people tell that it is written by Shakespeare. Some people tell no, it is not by Shakespeare. So how it is statistically analyzed to come to the conclusion is a very really interesting paper. Just give this search and go through that paper.
Anything else that anyone wants to ask? I would like to ask something. Hello, sir. Today, Professor Arnab Chakraborty in his second lecture taught us something, and to me, it was quite an act of pulling out the rug under one's feet, showing that how one cannot distinguish between dependence and independence. So, my question is, whatever we are doing till now as statisticians, what does it sum up to?
I think it would have been probably better if Arnav had responded to this, because if I give you a response, then I will be telling you my perspective, okay?
Yeah, so
it may not be what Arnav would like to say in response to your question, okay? Anyway, because he is not here, I will try to respond from my perspective, okay? See, I do not think there is a big issue in what he was talking about, okay? The problem is just like this. Forget about this problem of independence. Do you remember what Anirban asked at the end of his lecture? What did he ask?
How can one really distinguish between two normal distributions with
Exactly. So that's the problem. See, when he is talking about something is dense in some space, it's like this. What he is trying to say is that given any distribution, arbitrarily close to that distribution, there is a distribution where the two things are independent.
Yes.
Okay? Fine. So what? So when you are testing for normal distribution, there may be a mean that is close to the specified mean. So what he is saying is that if by chance your distribution is so close to the null, your test will not have any power.
Yes.
Okay? I never said that my test will have power 100% and 80% all the time. If my alternative is very close to the null, the test is not going to have power. We know that. The test has some limited distinguishing capability. That's essentially what he is trying to say. Probably, in order to make things interesting, he has presented it like that. And it's an interesting result if you think about independence and such things. Because people think of independence in a very strange way. I think the problem is what you think about independence. When you ask a probabilist what is independence, the probabilist, independence means the joint distribution is product of two marginal. Does it capture independence completely? I don't know the answer to that. That's a completely different conceptual or philosophical question. So, what he is saying is that there may be independent distributions very close to dependent distributions. So, then if you are testing for independence, your test might have not any power. See, I can turn around this issue and tell you something even more interesting what happens in practice, okay? We are talking about big data and large data these days. Then this problem of testing also doesn't work, because never you accept a null hypothesis when you have really large data. Every statistician knows that, okay? See, testing is a very disputed and controversial issue in statistics from the beginning, okay? When this concept of testing was proposed, great stalwarts in statistics debated about it. They are confused about it. There have been fights among statisticians on this issue, but testing has survived, which means it has some value. Okay? It may not have the value that we expect, but it has some value. Okay? So, I don't think he has said anything wrong. Okay, what he has said is absolutely correct. It's only an issue of how you look at things. Okay, it's your interpretation and perception. Okay, so you have a model. So so when you have a model, you would like to do certain things with the model. You would like to do certain computations with the model. You would like to use the model for making prediction and projection. Then, if your model has certain nice mathematical features, it's more convenient for you. Okay. So, I choose my class of models to be a nice class of functions, because then it is more convenient for you to do certain things.
So, it
and there may be very badly behaved model very close to that. Fine. See, always ask this question, what is the purpose? If your purpose is making prediction, you may be having two different, very different model giving you the same prediction. So for prediction purpose, they are equally good. If your purpose is giving scientific interpretation, then this question of domain knowledge, gut feeling, and all these things will come. But if you are just interested in making a prediction, a very unscientific model might give you very good prediction because the unscientific model is statistically close to the scientific model. That's all.
Thank you.
Okay. All right. So, there aren't any more questions. Okay. So, would you like to say anything?
No. I just expected people to ask questions and answer that. I have nothing. I have not prepared anything from my side. Okay.
Not as a member of the panel, but as one of the organizers, I would like to tell you that we expect all kinds of feedback from your side, maybe positive, maybe negative, any kind of suggestion, what you expected and you didn't get, everything. Okay. I know that you are not free to tell us now, but you do one thing, you have this IPCAM website. Coming 15 days, we will keep it open. Oh, it has been created. Okay. Google form has been created and link has been sent to them. Oh, it will be sent to all of you. So better you write whatever you want to write there, then we will compile all those things. Okay. We would expect that in another fortnight you will do it because after 15 days we have to close this site. Okay. So we will keep it open for 15 days. Okay. Thank you.